In our study of acids and bases, we need to start with water, and we want a way to measure a solution's concentration as an acid or base. But again, as I said, we need to start with water. We know that acids ionize. We've learned this before. So hydrochloric acid, when it's put in solution, 100% of the time it ionizes into hydrogen ions and chloride ions. We can say this another way. We can say that HCl plus H2O, because that's what this aqueous means, HCl plus H2O produces this ion that you may not have heard before, H3O, and that's called hydronium. And it is analogous to hydrogen. So if we, these are kind of representing the same thing, the hydrogen and the hydronium. And then of course, plus chloride. And these are aqueous, they're in solution. So we know that this happens 100% of the time with strong acids. Well, what about water? Does water ever ionize? Is it possible that water could ionize with itself? Does this ever happen to water? And the answer is yes, but very little. So in pure water, there is this hydronium, but its concentration is 0.000001 molar. That might seem insignificant to you. It is small, but it is certainly not insignificant. Well, you should know that this is neutral. So the hydronium is going to equal the hydroxide. So this also is the same concentration. Obviously, we could simplify this as 10 to the minus 7 molar, and hydroxide is 10 to the minus 7 molar. In pure water, they're going to be equal. So in pure water, the hydronium concentration, that's what those brackets mean, the molar concentration, equals the hydroxide concentration, which equals 10 to the minus 7. That's not the case, of course, in a hydrochloric acid solution, because we would be adding more hydronium. It turns out that if we were to multiply this concentration of hydronium times hydroxide, for pure water, we get 10 to the minus 7 molar times 10 to the minus 7 molar. That equals 10 to the minus 14. This is a very important number. It's important to remember that hydronium times hydroxide equals 10 to the minus 14, not only in pure water, but in all solutions. So we call that a constant. We call that Kw. K is our symbol for constant. That does not mean to say that hydronium always equals hydroxide. That's not what I'm saying at all. What I'm saying is the product of hydronium and hydroxide always equals 10 to the minus 14. Please remember that when we have exponents and we're multiplying those numbers, we just add them together, right? We just add the exponents together to get that number. So let's try some simple ones. What if I have a hydronium concentration that is 0.01? What would the hydroxide be, knowing that the product is always 10 to the minus 14? In other words, this is 10 to the minus 2 times something equals 10 to the minus 14. Well, we could set it up this way. We could say that the hydroxide concentration is going to equal 10 to the minus 14 divided by 10 to the minus 2. In this case, we would simply subtract the exponents, and we would end up with 10 to the minus 12. So it is important to be able to go back and forth between the hydronium concentration and the hydroxide concentration.